Assalamu alaikum students, welcome back to my YouTube channel. It's me Sir Abdullahlata. Okay, so today is a video in which we are going to calculate the non-graph. Okay, it means that non-uniform curve we are talking about. I know I definitely wanted you to know that how you are going to calculate the gradient of non-uniform graph. Let's see, student. If you are giving this graph, okay, student, be focused over here. Okay, time definitely, and we have definitely speed or velocity, and the graph is this. Okay, now as I told you that you are not going, okay, you are not going to apply directly the gradient formula. Okay, you are not going to apply, means ke sir, change in y divided by change in x is equal to y2 minus y1 divided by x2 minus x1. Sir, we can take, sir, x1 is definitely 2 and y1 is basically 10. Okay, then we are going to take, sir, x2 is basically, sir, 4 and y2 is, sir, basically 20. Then, sir, we are going to apply this for formula 20 minus 10, we will get 10. Definitely, sir, 4 minus 2, I will get 2. So I will get the answer, sir, 5 meter per second square. This is the acceleration. Student, this is the wrong way. As I told you, you are not going to apply directly this formula. Okay, because why, student? Why? This is the main concern. Because at every point, student, you have seen that speed is increasing. Speed is increasing and theta is changing at every point, student. It means that slope is changing at every point. So you are not going to apply this way like you applied in uniform speed, student, in this graph. Okay, you need to apply this technique definitely in this uniform graph or in which constant acceleration is there. But how would you solve if you are giving this graph, okay, non-uniform graph? Okay, student, how you are going to solve it? Okay, let's see, this is a picture of this graph. Okay, student, now how would you calculate the gradient, student? Now focus on the student. First of all, you are going to say that, sir, it is accelerating graph or it is decelerating. So now always remember one thing. As you see that, sir, theta is changing. See, theta is definitely increasing. Okay, theta is definitely increasing. It means that velocity will also be increasing definitely, and gradient means change of velocity will also be increased. It means that you will get the gradient increase, okay, which I definitely told in my previous video. Now how would you calculate, student? Do remember one thing. As I told you, you need to draw the tangent. Student, focus over here so that once you comprehend the thing, it will become piece of cake for you. Remember my words. Now this is a graph. You need to draw non-constant speed. Yes, sir, you are right. It is distance time graph. Student, always remember, speed at any point equals the gradient of the tangent. What does it mean? It means that at every point, if I calculated while using this tangent way, I can get the speed which is equal to the gradient. Okay, equal. For example, the gradient of the tangent. Gradient means, student, slope. Okay, change in y divided by change in x. Okay, now student, do remember, this is the graph you have been given. Okay, and this is the point which you need to find out. Okay, at this point. So as I told you, you are not going to apply this technique over there. Okay, no, you are not going to apply. Instead of, student, do remember, you need to draw this tangent line. Student, do remember my word, you need to draw. See over here, you need to draw this tangent line. Okay, you need to draw this tangent line. Okay, do remember one thing. Why? To get x value and to get the y value. Now I can apply the formula, sir, at this point display distance is 40 and I need to calculate the time. 4 minus 2. 4 minus 2 definitely 2. So I can apply the formula, student. Rise divided by run. Rise is y-axis 40. Run is 4 minus 2. 4 minus 2, I will get 2. 40 divided by 2, I will get 20 meter per second. Student, do remember, you need to apply this gradient technique either either you got the gradient increasing or deceleration. You need to apply the tangent wave. Do remember, you have many questions in past paper where you need to find out while applying this tangent wave. Okay, the speed at the instant means at every point corresponding to t minus tangent is therefore 20 meter per second. It means that at every point speed is 20 meter per second. I hope student you are getting this point by applying tangent wave and by applying gradient wave. The focus student equations for constant acceleration. When body is moving with constant acceleration, what does it mean? It means that body is moving with uniform velocity or body is moving in a straight line, can be explained by using equations of motion. Okay, we have 4 equations of motion, student. One by one we are going to cover. Okay, now first equation: if an object is moving with constant acceleration means uniform velocity. Okay, what does it mean? Uniform velocity means change is fixed, 20, 40, 60, 80. Okay, either increasing or you can say either decreasing. Okay, do remember my word. But in a straight line, and speed increases from u means student initial speed and v stand for final speed and time. Now we need to apply this formula, student. You don't need to memorize it, just understand and apply the formula. Acceleration, change of velocity upon time. Change means final minus initial upon time. Okay, time you are going to multiply over with acceleration, then you need to calculate the final speed. U is basically initial speed, will go over there, and you got V stand for student final speed. Always remember, if the examiner asks you to calculate final speed, student, so you need to apply this for and directly U initial, A for acceleration and T for time. Student, do remember one thing, students are misconcept. Okay, one thing, u means start of the motion, okay, of time. It is not necessarily, okay, it is not necessarily the body is always starting from 0 and you can just start of the motion. It can be start on the 40, 60 or 80. And similarly v means finish of the time of the motion. No, it is not necessary. It can be in a between line. Okay, so do remember, first equation of motion we are going to apply and we have to solve one question so that you have the idea which formula we are going to apply. Students, we are solving one question of first equation of motion. Okay, let's see. An athlete accelerates from rest at a constant rate of 0.8 meter per second square for 4 seconds. Calculate the final speed of the athlete. Now, student, do remember one thing, it is starting from rest. It means that initial speed and velocity definitely 0 means at rest, but it is not mandatory at every case. Okay, and acceleration, do remember one thing, student, we can judge most of the numericals by looking the units as well, by making the units. Remember my words, 0.8 meter per second square means acceleration. Okay, and a second for time. Then we need to find out the final speed. Now student, you don't need to memorize the formula, just apply final speed is equal to initial speed plus acceleration into time. This is first equation of motion. Initial speed is 0, acceleration multiplied by time, you got the answer 3.2. As you know that it should be round off, 3.0 meter per second is the final speed. Okay, in this way you can solve any question. Similarly, now student, second equation of motion. First equation you have done, that final speed is equal to the initial speed plus acceleration into time. Now if the speed of an object moving with, again I told you, constant acceleration in a straight line increases steadily, okay, its average speed therefore equals the half of sum of the initial and final speed. What does it mean? Student, do remember, average speed, you know that total displacement upon total time. Okay, now average speed initial plus final divided by 2. Okay, now do remember, if s is the distance moved in time t, then average speed, always remember student, if you have been giving 2 definitely only velocity, then you are going to apply this formula directly. But likewise, I told the question which I told you the formula. If you remember, you have been given the distance also. If you remember, the velocity is 50, and sorry, the velocity is 40, and the second velocity and 60, and it covers some distance. So you apply that formula over here. This formula which I told you, you are not going to apply that formula. You need to apply this formula. If you remember, 2v1 V2 divided by V1 plus V2. If you remember that concept, okay. So therefore, if you have been giving only two velocity and you are not giving any distance, then you are going to apply this formula. And if you have been giving the distance as well, okay, you are going to apply this formula. Okay. Now, average speed is equal to total distance amount of total time. Total distance is denoted with L. Student, do remember this symbols S upon T. Now I can replace this average speed, I can replace with S upon T, initial plus final velocity upon 2. Then definitely we need to find out the distance. Okay, T is gonna be multiply over here, and you got the answer. If the examiner asks you to find out the distance, you need to apply this. Student, do remember one thing, that we are dealing with third equation of motion. Okay, now from first equation of motion, student, we got final speed is equal to initial plus acceleration time. Now we know that the second equation is equal to speed, average speed is equal to average velocity. You know that v1 plus u upon 2. Why we are using this, student? We are going to get definitely third equation, so we can replace this v. Okay, we can replace this v with u plus at. Okay, once I applied over here, student, u plus at plus u, then 2u, definitely it have base 1, it also have base 1, definitely coefficient 1, then 2u plus at upon 2. Now student, I am dividing 2u upon 2 plus at upon 2. Now 2 has been, student, cancel out. So what is left over here? Initial speed plus at upon 2. Student, do remember one thing, we are going to get the distance, initial speed plus time, we are going to get this equation. Student, do remember it depends on the condition. Okay, like in equation number 1 we don't have any distance, equation number 2 we have distance, we can calculate with distance with this equation also. But definitely we need to get if we are giving acceleration, student, so we need to apply this formula. So depends on the condition and situation which formula is applicable. Now moving towards, student, fourth equation of motion. Okay, then we are going to solve 3 to 4 question where you can check yourself which equation of motion should be applied. Okay, now this is obtained by eliminating t from equation number 1 and equation 3. Now student, do remember this is again equation number 1. You know that final speed is equal to initial plus acceleration time. We are going to take the square, but do remember one thing, definitely you have done in your math also, a plus b is equal to a square plus 2ab plus b square. Do remember one thing, student, a is basically u and b is basically at. Okay, you are going to apply this formula, a square plus 2ab plus b the whole square. Okay, now student, I am taking the common, okay, I am taking the common, so I will get 2a. Now you are asking that, sir, we don't have any 2 over here, so but we can divide with 2. Okay, so that we get the answer half at square. Now you do remember, student, this is definitely equation number 3. If you remember, distance is equal to initial speed into time plus half at square. If you remember, we can replace this thing. We got the answer, final speed square is equal to initial speed square plus 2al. Student, do remember it depends on the condition ke either this formula is applicable or you are going to apply first equation of motion, v is equal to u plus at. Okay, equation number 1. Do remember, you need to memorize, student. There are so many questions. Okay, so if you definitely achieve for distinction or a staring, you need to work hard. Equation number 2, student, do remember standard is equal to average speed divided by 2 multiplied by time. It is not difficult, student. We are going to solve question. Then equation number 3, definitely we are getting s is equal to ut plus half at square, equation number 3 student, and equation number 4 is equal to v square is equal to u square plus 2a. Depend on the condition student that we are going to apply giving the acceleration distance. So in this way student, you once you start solving the question, now you need to write these 4 equation. Okay, now you are going to select yourself which formula I can apply and I can get the answer very easily. Okay students, now we are going to solve some questions answer so that we definitely develop our concept. Now, let's suppose student a sprint cycle start from rest and accelerate at 1 meter per second square for 20 seconds. Find her final speed and distance she traveled. Now student, do remember one thing. First of all, you are going to make this data, okay, for your safety. Definitely start from rest means initial speed is denoted with u 0 meter per second square, okay, and definitely accelerate 1 meter per second square means acceleration. Again, time 20 seconds. We need to find out the final speed and the distance. Now student, do remember, as I told you to write the formulas for you, okay, you can write the formula of every, because we have 4 equation, okay, so you can write the formula final speed equation number 1 initial plus 80. Okay, it will become easy for you to decide which formula is applicable. Okay, equation number 2, definitely s is equal to ut, okay, initial plus final upon 2 into time. Third equation, distance again ut plus half 80 square. Fourth equation, final square is equal to initial square plus 2as. Okay, so now student, why I am telling you to write these 4 equation, now you can decide, okay sir, this is the data we have, okay, this is the data we have got it, okay. Now shall I apply the distance formula? No sir, we need to find out first final speed, okay. How many speed we have been giving? Initial speed, acceleration and time, 3 things. Initial speed, acceleration and time, I can apply this formula, okay. So we can get the final speed. Why we are not applying this formula student? We know we do have time, we do have initial speed, we don't have distance student, we don't have final speed. That's why we are not going to apply even this formula, this formula. Are you getting my point? Okay, so you need to apply. Now I can apply formula initial speed plus a into t. I got the answer final speed. Very easy. Now distance, you have 2 formulas, initial plus final upon 2 into time, or definitely ut into half it is. But you have been giving over here acceleration as well, okay. You can apply student this formula also, initial speed into time plus half it is. You will get the same answer student. Remember my word, you will get the same answer. I am applying this formula, initial plus final upon 2. Definitely I got the answer 200. Let's suppose I can apply this formula so that you have the idea must be clear. Okay, sir, I can apply this formula. Okay, S is equal to initial speed, I have 0. Time I have been giving sir 20 seconds. Plus half A acceleration sir I have 1. Time I have definitely sir 20. Okay, 0 into 20 is definitely 0 plus, okay, half a t square, okay. Now half 1 remain 1 definitely 20 into 20, okay. Now 0 definitely it is not worth half. 20 times 20 student, do remember 400 is divided by is equal to 200 meter. Okay, so either student you are applying this formula or this formula, you will get the same answer. Definitely I have solved in front of you also, so that your concept must be clear like a crystal. Okay, why we are not applying this formula sir? We need to find out final speed. Yes, I can apply student this formula as well. Okay, final speed I have been giving, initial I know 2a x is giving, as I can apply this formula also. You will get the same answer. Okay, now moving forward student, we are solving 2 more questions. Okay, a cyclist increases speed from 10 meter per second to 20 In 5 seconds, calculate average speed. I told you when you have been giving only two speeds. So do remember, this is u means initial speed and this is final speed. Just add and divide it 5, you will get the answer. Now, calculate the distance means you are going to find out the s. Move by a car, accelerate from rest means initial speed student 0. You are making this data in your mind, okay? And at a constant rate, this acceleration definitely time. Now we need to find out the distance. Now again you come over here. Yes sir, which this is the condition you have, UAT you have, okay? Now UAT you don't need to find out the final speed, okay? We are not going to apply this formula. UAT, why we are not applying this formula student? Because we don't have final speed, we don't apply this formula, okay? Now shall I apply this formula, sir? I don't have final speed, again I can't apply this formula, has been cancelled out. This is also, now we can find out this formula, ut plus half at square student. U into t means initial into time plus half at square. Student, do remember one thing, student mostly confused over here. 5 square doesn't means a 5 into 2 means 10. This is wrong student. Definitely slightly mistake must be done in the exam due to pressure. Do remember, square means you need to multiply by itself, okay? Do remember, these are the small thing must be clear, okay, while you have applied the correct solution, even though you are not getting the same answer, okay? So definitely it hurts a lot. So we can see that sir, 2 into 2 has been cancelled out, 5 into 5 25, and 25 ones are this answer. I will got the answer. So in this way students, I hope your concept has been cleared by solving equations of motion along with the non-uniform graphs. Thank you.